Welcome to the Women in AI Research podcast. I'm your host, Ekaterina, and this week I'm at NeurIPS 2025 in San Diego.
Thank you so much for waking up so early. I don't even know what to say. It's an incredible honor to speak for NeurIPS Keynote. So today I would like to tell you about the art of artificial reasoning. And here's the mission statement, Mission Impossible. Democratizing generative AI by transforming scalable models.
And converse with you in fluent natural language, we can't help but ascribe certain kinds of human qualities to that system.
Hello, so could you please introduce yourself?
Yes, I'm Melissa. I'm a second-year PhD at UC Berkeley, working on broadly in the direction of systems and agents. And I'm advised by Professor Matej Zaharia. So I'm here today to present our work. Why do multi-agent LM systems fail?
Yeah, can you walk me through the work?
Of course. So people say the year of 2025 is the year of agent. Now we're at the end of the year. We can probably pretty confidently tell that this is true. We have seen many excitements about, and then many fascinating capability that agent or potentials, if that's how we that agent demonstrate. But when we take a closer look at the popular multi-agent system, we find out that they actually fail more than half of the time on average. So it leads us, it really signals a huge reliability challenge that currently exists. And in order to build more reliable multi-agent system going forward, we need to first understand why do they fail. That's why we set out this study where we study across 7 open source framework, 1 closed source framework, and then across 8 different benchmarks, 3 different task domains to build mass. So it's the first multi-agent failure taxonomy that includes 14 unique failure modes that span across 3 failure categories. So the first failure category is system design issue. It relates to how you architect your agent system or workflow. And we show that by using the same underlying LLM, you're actually able to get about 9% improvement on downstream tasks by just changing the design of your multi-agent system. And then the second type of failure is inter-agent misalignment. So for this type of failures, it's related to things could go wrong in the runtime execution of the agent. So for example, if you and we are solving a math problem together, it can become you teaching me math theorems. So we never ended up solving the task together. Yeah, and then for the last type of failure modes is task verification. It's related to how you control the final quality of your agent output. So we all know verifier is important. But when we take a closer look, we found out that a lot of the checks that the verifier currently do are very superficial. So for example, if I check if my code compiles, if I get any syntax error, or if there are leftover to-dos that are not being implemented. So these are not rigorous enough when you compare to traditional software engineering. So we think that there are a lot of lessons that we can take from say doing unit testing, more multi-objective test cases in order to build in order to improve the performance of agentic system. So I guess if there's only one takeaway message that you should get is we are pretty bullish on the future of multi-agent system. If you look at the history of how software evolved, but they currently have huge reliability challenges. And in order to build more reliable system, we need to fix these errors. So that us as a whole agent community can have a better agentic system going forward.
All right. And why do you think, what's your intuition, why those percentages of failure are different? It looks like the first system design issues are the most important probably, or the most frequent?
Yeah, that's a very good observation. So it really depends on what is the system that you're building, and then also what is the task that you're trying to solve. So in the framework that we study here and all the benchmark we study here, system design is a huge reliability issue. So basically, we show that by improving the design, you can get better performance. But this might not be the case across the board. So we have seen people who are trying to apply math to their domain or their use cases, and then they have a different distribution. So that's also totally normal because they have different use case, they have different design, or maybe they have a very good system design, so they don't have as much like system failures. So yeah, it really depends on the use case.
So, for example, if using some specific model, is it also the system design issue?
Yes, that is. So we actually show like one example where you can use math to analyze if like some model is better for your task or not. So for example, here we do like the failure mode breakdown by comparing GPT model and then Claude model. And then we actually, like particularly here, we find it quite interestingly surprising that GPT has like less failure modes than Claude. So it really depends on what the task you're trying to solve.
Have you seen any differences across sizes of the model?
Okay, yes, that's a very good question. We didn't particularly try to like compare the sizes of the model, but that would be very interesting. Yeah.
Right. Do you have any follow-up work planned within this area?
I mean, we actually have a lot of exciting directions related to math. So like, for example, people are trying to like use math data to like maybe weight tune their agent to like lead to better downstream performance for their specific task. We also have like another line of work where we try to apply math to like different domains. And then we also like try to look if there's way to like self-evolve like the taxonomy, because you can imagine the field of agent is like growing very fast. So like this is not a static taxonomy. So how do we like efficiently and like come up with a new taxonomy is like also another line of work. And then there's also like people like, for example, agent observability is like a hot area of research right now, where like at the runtime, how do you make sure your agent is working correctly? And then maybe like apply the fix at runtime. So that's like also another direction that like people at the labs are looking into.
Okay, I'm looking forward to your new papers in this area.
We actually are going to release something really soon where we look at the successful cases of agent in production. So yeah, stay tuned. We are going to release it very soon.
Amazing.
Yeah.
Thank you very much.
Thank you so much.